Section 11.10, solving differential equations. So first of all, let's just address the fact that you have already been solving differential equations. So last year, when you had dy dx given, so the derivative of function y, and you were told that it's 3x squared, you could find the actual function that differentiated to this by integrating it. So as a matter of fact, when you integrate dy dx, you are going to reverse differentiation, so you come back to y. And when you integrate 3x squared, you are going back to x cubed, allowing for a possibility of having a constant at the end, so you put plus c. So this is actually a general solution to this differential equation, and this curve, so the cubic curve plus c, represents a family of solutions. So a family of curves or solutions. So we're going to extend this idea to a little bit more difficult functions. So the ones we're going to be considering in the second year of A-level mathematics are when you've got two functions, one in terms of x and one in terms of y, and they are combined together through multiplying or dividing. So you've got dy dx in the question, and you've got a function of x and a function of y. If you, in general, if you've got this combination, and you can rearrange it by, I'll show you how, through multiplying and dividing. That means you can use separating variables method. So here the idea is to temporarily treat dy dx as if it were a fraction, and the line between dy dx as if it was a fraction line, so dy divided by dx. So the idea is to move all the x's onto the right hand side together with dx, and dy stays on the left hand side, but all the parts of the expressions, the equation involving y's, need to be moved through multiplying or dividing onto the left hand side. So you're going to put all the y's onto the left, all the x's onto the right. So you've got, in this example, dy over dg of y equals f of x dx. Of course, this doesn't make sense by itself. You might want to write it as 1 over g of y. It still doesn't make sense. So we're going to make it legal and more something that we can work with by putting the integral symbol in front. And this tells us now, let's integrate it. Let's undo this differentiation. So once you are able to integrate it, you might be able to find y in terms of x, or you might not be able to find y. You might be allowed to leave like sine y equals to something as a solution. That's perfectly fine. This will be a general solution. What you must remember is that you put plus c, and you put plus c only on one side of that equation after it's been integrated, so not on both. If you are given what's called a boundary condition, so that gives you maybe a point on that curve, then you'll be able to substitute it into your general solution and to find that constant c. So here are the steps. So it needs to be a product or a quotient of those elements. So you need to have dy dx and have f of x and g of y. You are going to move y's onto the left hand side, move the x's and dx onto the right hand side. But when I say move, multiply or divide only. You are going to put the integrate symbol in front of these expressions to make solvable. Solve them, so integrate it, and then put plus c only on one side. Normally we'll put it on the side with x's. So let's have a go at the first example. So the first example of that section is example 26. So here we've got all the y's on. Remember, you've got dy dx, that element is there. These are all parts involving y's, so these will be moved onto the left hand side. The other side, you can say, well, that's y. Well, y can be it's together with x squared. Kindly they put it in brackets, so any constant can be moved with a variable as long as it can be thought of as a whole function, so as one bracket, and you can do it by multiplying and dividing. So the pink bits, the dx and 1 plus x squared, can be moved onto the right hand side where you already have 1x there. So when you divide through by tan y, you'll have 1 over tan y dy on the left hand side, and when you divide by 1 plus x squared and then multiplied by dx, you have these bits on the right hand side. Make it legal by putting the integral, and you are able to integrate it. Don't forget 1 over tan y is cot y, and you should realize that this is a standard function in the formula booklet. You've got the result you can quote. It goes to ln modulus of sine y. On the right hand side, you might be very quick and spot it that the denominator has 1 plus x squared. That differentiates to 2x, and you have got half of that answer in the numerator, so that should go to half of ln 1 plus x squared. If you are worried you're under test conditions, under the exam conditions, always check it. Maybe replace the idea is to replace the denominator, so the harder part, by u. So differentiate it, so use substitution. 2x, rearrange it, du is equal to 2x dx. So that tells me x dx can be replaced with a half of du. There you go. So in here I've got x dx, this is that bit, that's a half of du, and you've got u in the bottom, so this, if I take that half out, you've got 1 over u du, so that's going to be a half of natural log of u, plus c, which is ln of 1 plus x squared, and that's always positive, so I don't need modulus. Bring the half as the power. Now if you notice on the left hand side you still have ln of sine y, so we can combine the whole answer by turning into logs. So we can replace c with ln a, so ln a, and now we can combine them. So you've got ln product of a and 1 plus x squared to the power of a half, you can write it as a square root, and then sine y. Now the book doesn't make a lot of fuss around dropping ln's, and they just write sine y equals a and 1 plus x squared to the power of a half, which is correct. You can leave your answer like this, provided you realize a could be positive or negative. Although when you look at this definition, that a is always positive, so you might, but don't worry about it. If you if I use that definition that a is always positive, then here I would have to put plus or minus a, 1 plus x squared power of a half. But then although they use this definition, they go back to that, which means that a can be positive or negative. Anyway, so that is the solution to our question. Okay, now let's move on to example 26. So this time we are going to show you, I'm going to show you how to use boundary conditions. So we are still going to solve differential equation by separating variables, find the general solution, and once you've got the general solution, we're going to substitute the coordinate of the given point and to find that constant c. Okay, so over here, let's just check. Yeah, we can nicely move all the y's to join forces with dy, so the whole bracket here can be divided through. You could move minus 3 as well, but I'm going to leave it on that side. And then you've got the x's will stay, so minus 3 and x's will stay on that side, and the x will move over here. So we'll divide by y minus 2. And then we will have minus 3 over 2x plus 1 left, multiplied by x plus 2, and then dx as well. Let's put the integral, and this will go to ln y minus 2. And this here is a fraction. We're going to use partial fractions to find the solution to the right hand side, to the typical partial fraction question. So replace it with a over 2x plus 1 plus b over x plus 2. So either think of multiplying through by 2x plus 1x plus 2. So with the first one, you will, first of all, these will cancel and these will have a times 2x plus 2. So it's got 2x plus 1, so you give it what's missing. And this one will be given 2x plus 1. Alternatively, you might want to think of that as multiplying through by x plus 2, so bringing the right hand side to the common denominator. I don't mind how you think of that, as long as then you compare the numerators and you arrive at this result. So over here we are going to substitute x with minus 2 to make the first bracket disappear. You'll be left with minus 3. That will go to 0. You have b, and 2 times minus 2 plus 1, that gives me minus 3b is equal to minus 3. B is 1. The second value we're going to substitute is minus a half. So you have minus 3 still on the left hand side. Over here you have a minus a half plus 2. This will go to 0. So we have minus 1 is a 1.5 IA, sorry, is equal to minus 3. So a is minus 2. So the replacement for the right hand side, a was minus 2 over 2x plus 1, plus b was 1. Let's integrate. So this one you don't need to do any substitution. You can see that this is going to be minus 2 lots of ln 2x plus 1, but we'll need to divide by 2. So 2x plus 1. This is just simple natural log. And then don't forget plus c. And you've got ln of y minus 2. You can find c first, and then we can combine it. Or, like I said, we could actually find a general solution. It doesn't matter which way around you do it. So I'm going to find the general solution. In case in future you just have to find the general solution. So that's going to be minus ln 2x plus 1. This is ln x plus 2. So I'll put ln x plus 2. I'll write this as ln a, and minus ln 2x plus 1. Combining these, I'll have y minus 2 is equal to ln. These two will go in the numerator, and this one will go to the denominator. Okay, so dropping ln, again the same argument would apply as before, but the book is not really that fast, as long as a is at this stage positive or negative. We can find the value of a by substituting. So this is the general solution if you make y the subject. Let's substitute these values. What shall we get? We're going to get 4 minus 2 is equal to a, and that's going to be 1 plus 2, which is 3, and then 2 times 1 plus 1, which is 3 again, giving us a equals to 4 minus 2, which is 2. So over here we've got y is equal to 2x plus 2 over 2x plus 1 plus 2. So you can either bring it to the common denominator, whichever form they want to, or which in that case is going to give you 2x plus 4, and this one will have to be multiplied by 2x plus 1, so you get 4x plus 2 over 2x plus 1, giving us y is equal to 6x plus 6 over 2x plus 1. Alternatively, you can do what the book does, so it divides by 2x plus 1. So how many 2x plus 1s have you got in 6x plus 6? So there's 3. 3 times 1 is 3. So then we have extra 3, so the remainder is 3. So that gives us 3 whole, and then remainder is written as 3 over 2x plus 1. So 3 plus 3 over 2x plus 1 is the solution in this form, or in this form also if you prefer. So this takes us to exercise 11J.